Welcome to this AnalyzerPro tutorial. In this tutorial you will learn to deal with the main data mask and the distance time data respectively. You can open the main data mask for each vehicle in this upper middle bar. Please open it for vehicle number 1 now. The main data mask is the crux of the matter of the entire program. All calculation, be it in the modules, in the collision analysis, etc., end up in this main data mask. Only data that is entered in this main data mask is also displayed in the kinematics window. Please note that by default you are always in the kinematics window of AnalyzerPro. You will also see in the upcoming tutorials that even kinetic calculations are exported to this main data mask in the end. However, you can also directly do some calculation in the main data mask. Let's look at this option first. The first question you have to answer is whether you are dealing with a forward or backward calculation. This has nothing to do with driving directions, it rather states whether you are dealing with starting value problem, or end value problem. If we know the end conditions and would like to know the initial conditions, we choose the backward calculation. If we know the initial conditions and would like to know the end conditions, we use the forward calculation. Usually you rather know the final position of an accident. That's why backward calculation is set as the default option. In the middle area of the window, you can see phases, here ranging from 1 to 7, with a maximum of 48 in total. As a basic and essential principle of AnalyzerPro, movement sections are split up into different phases which are subsequently added to another. This way entire driving sequences can be analyzed efficiently and fast. Let's clarify this with an illustrative example. Imagine that you see a vehicle that is obviously just braked. Maybe you can see skid marks on the ground in some form and the vehicle is at a standstill. In this case a backward calculation is indicated. Therefore, the first phase we will look at is the chronologically last one. What has the vehicle probably done before the standstill? It probably has braked. So let's choose a brake phase. Now we have the possibility to insert 5 parameters. 3 of them have to be stated. The others are computed. Which 3 parameters could we possibly know? The first parameter is relatively simple. The final velocity can remain 0, as the vehicle is at a standstill. Next, we need to think of the deceleration the vehicle could have had. Depending on the weather conditions, braking behavior and other factors we can reflect on the deceleration. On the left area you can also find a drop-down menu that suggests certain values to us. Let's choose a rather strong brake with 7 meters per square second deceleration in our example. The third value is still missing now. We will probably not know time or initial velocity, but maybe we can measure a brake distance based on the skid marks. Let's assume that we have a brake distance of 5 meters in our case. If we click on Calculate Now, we see that the other 2 parameters have been calculated automatically. We see that the braking behavior we have defined requires a time of 1.2 seconds and an initial velocity of about 30 km per hour. Now let's move on to the next phase before the vehicle has fully braked. This is the so-called build-up phase. The time the vehicle needs to apply the full braking force. When we select this phase, the deceleration is automatically transferred from the phase before, because the brakes obviously build up to this value. By default, the program enters a time of 0.2 seconds, however you can of course adjust this value. As we have heard before, we need 3 parameters per column. So what could be our third parameter? As phase 1 and 2 are connected with each other, the final velocity of phase 2 has to be equivalent to the initial velocity of phase 1. This is a basic principle that applies to all phases of course. You don't have to copy the value 30.12 now. You only have to click on Calculate and the program will automatically transfer the velocities as it assumes that they are the same. When we click on Calculate, the respective parameters are again calculated. And we can see already that we have been a little bit faster at the beginning of our braking process. Before a vehicle brakes, the driver has to react most of the time. Therefore, we must select a reaction phase. If we assume that our driver has not braked during the reaction phase, then we end up with the minimum of 3 parameters pretty fast. The final velocity is equal to the initial velocity of the previous phase again. The deceleration is 0 in this case and the time needed for the reaction is assumed to be 1 second by default. Please note that this value is just a reference value and has to be adapted to the specific situation. Let's assume that the reaction time is shorter in our case and insert a value of 0.8 seconds. Before the driver can react, he has to recognize the hazard first. For this purpose, we choose a recognition phase and indicate a time of 0.4 seconds. During this time the vehicle drives with constant velocity, at least we assume this in our case. Finally, let's assume that the driver was driving with constant velocity in the beginning. After we have clicked on Calculate, we see the respective intermediate results in our columns: the total covered distance, the velocity at the beginning and the total time of driving sequence. Now it might be the case that we want to change parameters afterwards. We can immediately change the input fields that are activated here and press on Calculate to receive the new result. A major strength of AnalyzerPro is that we can increment the calculation values and view the adapted results simultaneously. Please click on the field and use the arrow buttons upwards and downwards to change the input values. You can see how the respective values change automatically. You can use the increment function either with the little buttons next to the input field or with the arrow buttons. Keep the Control key pressed to change the second digit from the right. Keep the Shift key pressed to change the third digit from the right. You can find the increment function throughout the whole program. It helps a lot to find the correct values when you do not know them exactly before the analysis. As you can see, with the calculation of the vehicle data, a vehicle has been automatically placed in the kinematics window. Only if data is indicated in the main data mask, the vehicle is displayed. It is not possible to position a vehicle if no data has been calculated before. If you would like to calculate a whole column anew but you do not want to lose the values, you can select the respective column and click on Init. It means initializing. The entire column is emptied then and you can change all values again. If you want to delete one or several columns completely, please use the Delete button for it. This tutorial is one of the most important of the entire tutorial series, as it builds the basis for understanding AnalyzerPro. Thank you for watching and have fun practicing.